Now, we've talked a lot about estimating the uncertainty in a single quantity, but in any real experiment you do, there's going to be a number of things that you measure, and you'll want to combine those into the quantity that you're really interested in. So the uncertainties are also going to combine, but in a slightly different way to the quantities themselves, and that's what this video is going to be about. We need a few more terms before we go on. The measurements you collect are called the raw data, and when you combine them in some way, you are calculating a derived quantity. Now, the raw data has an uncertainty that you've estimated from the instrument scale and the measurement procedure, and this uncertainty is called the absolute uncertainty. We can also express that as a relative proportion or percentage, and this is useful for comparing measurements at very different scales. So an uncertainty of 10 kilograms is very small if you're weighing a truck full of apples, but it would be very large if you're recording the weight of a box of apples. And if you're trying to determine the mass of a single apple, an uncertainty of 10 kilograms makes your measurement completely meaningless. As a quick example then, let's suppose I've weighed a tray of apples and it's 7.56 plus or minus 0.4 kilos. The 0.04 kilograms is the absolute uncertainty, and expressed as a relative error, it is 0.005, or as a percentage, just 0.5%. Notice how the absolute uncertainty has a unit associated with it, but a relative error doesn't. Now there's also a nice connection here to significant figures. The number of significant figures gives you the order of magnitude for the relative error. 3 significant figures means the relative error is around 10 to the minus 3. And if you want to keep the errors in your combined quantities comparable, then you should always try to measure everything in an experiment to about the same number of significant figures. Now let's get into the real business of how to combine quantities and uncertainties. If I add two quantities together, then I must add their absolute uncertainties. So for example, if I have that tray of apples and a tray of pears that weighs 6.23 kilos, then the total weight is 13.79 plus or minus 0.08 kilos. If I also add in a tray of oranges that weighs 8 kilos or so, then I calculate the total weight is 21.81 kilos and the total uncertainty becomes 0.12 kilograms. Now my uncertainty is increased to more than one significant figure, so I have to change the way I write this to be 21.8 plus or minus 0.2 kilos. We always round up the uncertainty just to be on the safe side. But notice that I've still got 3 significant figures in my total weight of the 3 trays of fruit. Each measurement started with 3 significant figures, and when I've added everything together, I've still got 3 significant figures at the end. Now suppose I know that the box the apples are in weighs 245 grams, plus or minus 8 grams. So in kilograms, that's 0.245. And what's the weight of the 2 dozen apples I've got in there, not counting the weight of the box? So I have to subtract the quantities, but I still have to add the uncertainties. So I find when I subtract the weights, I get 7.315 kilos, but I add the uncertainties to get 0.048 kilos. Now again, I have to turn this into sensible numbers of significant figures, so my final answer should be 7.32 plus or minus 0.05 kilos. Now what if we multiply two quantities together? In this case, we must add the relative errors to get an overall relative error. The simplest example of multiplying measurements I can think of is calculating areas. So suppose my tray of apples is 53.0 plus or minus half a centimetre wide and 92.5 plus or minus half a centimetre long. Then according to my calculator, its area is 4,902.5 square centimetres. But what's the uncertainty here? The relative error in the width is 0.01 and the relative error in the length is 0.005. So the overall relative error will be 0.015 and the estimated absolute uncertainty in the area will be calculated like this, and that number there is 74 square centimetres. Now, turning this all into sensible significant figures again, we should report the area as 4,900 square centimetres plus or minus 80 square centimetres. Now notice here how I've written the quantities in standard form to emphasise the fact that the 0 here is a significant figure. And you should also notice how my starting measurements had 3 significant figures and my final quantity also has 3 significant figures. The fourth way we combine numbers is using division. And again here we must add the relative errors for the quantities involved. Now the simplest example of dividing quantities I can think of is calculating speeds. So let's figure out how fast I can swim a lap of a 50-metre pool. The length of the pool is really precise. We know it within 1 centimetre. But I have my 6-year-old daughter time me with a stopwatch, so there's an uncertainty of 1 second in my time, which was 43 seconds plus or minus 1 second. The relative errors are 2 times 10 to the minus 4 in the length and 2 times 10 to the minus 2 in the time. My average speed for swimming this length of the pool is then 50 over 43, which is 1.16 metres per second, with a relative error of 2 hundredths. The error in the length is so small it doesn't really contribute. Now I can use this to calculate the absolute uncertainty to be 0.023 metres per second, so we'll report the result as 1.16 plus or minus 0.03 metres per second. What about if you have to use your measurement in a function? Say you measure an angle, but you need to evaluate the sine of the angle. Then the most straightforward way to estimate the uncertainty is by plugging in some numbers. You have to evaluate the largest and smallest possibilities for your measurement and see what range of function values that gives you. A more rigorous approach uses calculus, but we won't go into that here. Let's finish with a quick summary of how to combine uncertainties. If you add or subtract 2 measurements, you must always add their absolute uncertainties. If you multiply or divide 2 measurements, you add their relative uncertainties. And if you evaluate a function, then estimate the uncertainty by plugging in the appropriate numbers. The important point here is that uncertainties always add, and the number of significant figures can never increase.